Here is the start of Unit 7. We're starting at the beginning here. We're talking about the multiplication properties of exponents. And so I just want to first start off by explaining exponents and what they are. And so when we have a variable, remember a variable is just a placeholder for that number. And I say I have y squared. This is just a nicer way of writing y times y. And so let's say I have a larger number, like y to the 5th. That would be y being multiplied together 5 times. So we use exponents as a shortcut, so that way we don't have to write out y times y so many times. That's our exponent. So let's get into the first type here. I have the product of powers here. And so what I'm saying is that a to the nth power times a to the nth power is equal to a time, or to the power of n plus n. So let's say that I'm taking a to the first to the second times a to the third. That would give me a to the 5th. And you don't have to write that down because we're going to simplify here. I'm just giving you an idea of what this means. And so if you're like, why does that make sense? Well, think about what each exponent is saying. I have two a's here, a times a, and if I multiply that by a cubed, a times a times a, how many a's do I have? 5. So I'm going to say that's a to the 5th power. So let's look through some examples like this. So for this first one right here, I have y times y to the 5th power. Well, what is that exponent of this y right here? It's to the first power. Anytime you don't see an exponent, it's our invisible 1 rule. So what is 1 plus 5? 6. So I'm going to say if I multiply those two together, I get y to the 6th power. Okay, I have m squared times m to the 7th power. I have 2 plus 7, so I have m to the 9th power as my simplified answer. Here I have x to the 4th times x to the 3rd. I'm adding the 4 and 3 together. I get x to the 7th power. And then finally I have n to the 5th times n to the 3rd. When I multiply, I get n to the 8th power. I'm adding the 5 and 3. So pretty simple enough. Okay, but let's talk about one that's a little bit more challenging here. We want to simplify all of these things. We have now multiple variables all at once. We have an a, b, a c, we even have some regular numbers. It doesn't matter. We're going to treat it the same way. So what I recommend is either using a highlighter or underlining each different thing to help you separate what's going on. So in one color or in like an underline, one underline, I would say 4 times negative 3. I'm looking, what can I multiply together that looks the same? So I can multiply this 4 times a negative 3 to give me negative 12. Then go to a different color or double underline all of your a's being multiplied together. Because remember, I can only multiply things that look the same. I can't combine other stuff. So then I have a cubed times a squared. In other words, what is 3 plus 2? 5. So I have a to the 5th power. Then I'm going to use a different color or just do like 3 underlines. I don't know. The b's. So I'm saying I have b, invisible 1 rule to the 1st power, times b to the 5th power. 1 plus 5 is 6. And then finally, c to the 1st power. I don't have a c over on this side, so I'm just going to bring that down. So simplified, this would be my answer. Okay, so that is the product of a power rule. Now I have another rule that is if I'm multiplying a power to a power. And so what that means is if I have a to the nth power, and then I take that whole thing to the nth power, I am multiplying a times, or to the m times n power. So this time I'm not adding the 2 like I did before. There's something different. Here, these were just being multiplied together. Now, I'm taking this power to this power. So we are being multiplied. So looking at y to the 5th power to the 2nd power, I multiply the 5 times the 2 to give me a 10. Here I'm taking x squared to the 5th power. And so I have this x cubed over here, but I'm not going to deal with that yet. Because remember, when I do my problems, I'm going to read from left to right. We're following order of operations like we've been doing this whole time. I'm going to simplify from left to right. So I'm going to take x to the 2nd power to the 5th power. I'm going to multiply 2 times 5 together to give me 10. Bring down the x cubed being multiplied. I haven't done anything with that yet. This is where I'm no longer going to be multiplying the 10 and 3 together, because this is not a power-to-power situation. This is a product of power situation. It looks just like this. I'm multiplying them. So now, to simplify, I need to say x to the 10th power times x to the 3rd power is x to the 13th power. I'm adding them together. Then I have x cubed to the 3rd power. Multiply 3 times 3 to give me 9. And then I have another situation here where I need to simplify each power to power first before I multiply those together. So you need to simplify those parentheses first. So n cubed to the 2nd power, 3 times 2 is n to the 6th power. I'm multiplying that by n to the 4th power being cubed, so 4 times 3, n to the 12th power. Now, those two are being multiplied, so I'm going to add the 6 and the 12. It's not a power to power. So I'm going to say this is n to the 18th power. It's my final answer. Okay, this one right here, same idea. I'm going to simplify, multiply the 5 and the 3 together because it's a power to power situation. Okay, the final thing is a product of a power, and so this means that I'm kind of combining the idea above that we talked about, but with multiple variables inside the parentheses. So notice that the problems that we did above were only one variable inside the parentheses being taken to a power. Now I'm just going to have two, right? I had only n's, I had only x's in my parentheses. Now I'm going to have multiple. It doesn't change anything. It just means that we have to take each individual variable and each individual number to that power on the outside of the parentheses. So what that means is I'm really taking -4 to the 3rd power, x to the 3rd power, y to the 3rd power, and so on, right? So -4 to the 3rd power. If you're unsure of what that is, you can always type it into your calculator. Or think about it as, what is -4 times -4 times -4? That is -64. Then I'm saying, what is x to the 3rd power? Well, I multiply those exponents together, right? X to the 1st times 3, well, that's just 3, x cubed. Y to the 1st power cubed, 1 times 3 is just 3 again. I'm multiplying this whole entire thing here by -2x cubed to the 3rd power. So I need to simplify that first. So again, I'm taking this -2 cubed. So in other words, what is -2 times -2 times -2? Use your calculator or do it in your head, it's -8. Then I have x squared cubed, which then is 2 times 3. I get x to the 6th power. So now I can no longer be following the power to power rule because I don't have anything being raised to a power double, if that makes sense. Now I'm just going to go back to the product of a power rule where I'm just adding each exponent together. So that means I'm going to take, well, -64 times -8. I'm doing that first. That I can multiply together. I don't have any exponents there, so that gives me 512. Then I have x cubed times x to the 6th power. I'm adding those to give me x to the 9th power. And then I have y cubed. And I don't have any y over here, so I'm just going to bring down this y cubed here. So it is very easy to get lost here. There are a lot of numbers, lots of things being either taken to the power or being multiplied. So you have to make sure you know the difference. When you have a number outside of your parentheses like this being raised up, that means you're taking that number and multiplying it to each individual little part and making that its exponent. But if you have something like this, that they're no longer being raised to a power, they're just being multiplied, then your exponents are being added. Okay, so let's try another one again. So same idea, I want to simplify this exponent here on the outside before I start adding my exponents together, on the inside. So I'm going to take the negative 3 cubed, which is negative 27, m squared cubed. I'm multiplying those two together, so 2 times 3 is 6, and n to the 4th power cubed. Taking those two, multiplying them together, 4 times 3 is 12. That is all being multiplied by 2n to the 5th to the 4th power. So I'm taking the 2 and I'm taking that to the 4th power here, and then that gives me 16. And then n to the 5th power to the 4th power, 5 times 4 is n to the 20th. So I no longer have a power to power. I'm now going to look and start adding my exponents together that look, using the same exponents and the same variables, right? I'm not going to mix an n and an m together. I'm only going to keep my m's, add those exponents together, my n's, add those exponents together, and so on. But I can multiply my two constant numbers here, negative 27 and 16, which gives me negative 432. And then m to the 6th power. Well, I don't have an m over here, so I'm just going to bring that down. And then I have n to the 12th power plus, or being multiplied, n to the 20th power, but you're adding the 12 and the 20. So that gives me n to the 32nd power. And that's my answer. And so the one right here, this one isn't as complicated because you're only taking the 3 and you're no longer multiplying two entirely different terms together. We now have, it's just 1. So this one's a little bit nicer. So I'm still going to take the 3 cubed, which is 27, a to the 2nd power to the 3rd power, so 2 times 3 is 6, and then b to the 5th power to the 3rd power, so 5 times 3 is 15, c, invisible 1 rule, 1 times 3 is 3. So that's my answer.